Okay guys, so this is going to be lesson 5, a little bit longer, but you really need to pay attention, follow closely, and go back to your notes when we're done with this lesson. It's going to take a couple times to understand what's going on here. So it's called Le Chatelain's principle, and this actually explains how a system is going to react to certain things when it is at equilibrium. So Le Chatelain's principle explains how a system will respond to a stress. So a system at equilibrium will respond to a stress. And what is a stress? Well, stress is any change in temp, concentration, or pressure put upon a system at equilibrium. Remember, it is a closed system. So when a stress is added to a system at equilibrium, the system will shift. Okay, the system will shift in order to relieve the stress and reach a new equilibrium. A shift is an increase in the rate of either the forward or the reverse reaction. So shift toward the right, which means it's going toward the products, is the rate of the forward reaction, and then what will happen is it will actually increase because it's favoring the products. So the arrow will just go toward the right, and the reactants favor going toward the products versus the reverse reaction. So favors products. Okay, now shift to the left, going back, so that would be the reverse reaction toward the reactants. The rate of the reverse reaction increases. And that's when the arrow goes back this way. Okay, so this is favored versus going forward. So that would favor the reactants. A little confusing, but maybe it'll be clear as we go through all of the stresses. So the first stress is concentration as the initial stress. So equilibrium will change or shift when a reactant or product is added or decreased in a reaction that is at equilibrium. So either we introduce something new or take away something. Okay, that's going to actually change the equilibrium, and it's got to go to the opposite direction or toward it in order to balance it out. So when the concentration of a reactant or product is increased, now this is very important, so we're talking about the increase in concentration, the reaction will shift away from wherever the increase occurred. Okay, and it's going to use up the excess, which means then whatever is on that side that was increased, everything else on that side is going to decrease. So if we add water to this system here, okay, and water is a product, right? So we're adding product. That means that the shift is going to go away from that, so it's going to go toward the left. And the NH3, now we have to look for the NH3, is a reactant. That would increase because, remember, when we shift to the left, the reactants are going to be favored, so we have an increase in reactants. If we add O2, so now I need to find the O2, which is right here. Okay, that is a reactant. So if I add reactant, it's going to shift away, which means it's going to go to the right. And the NO, the concentration of the NO, which is a product, would then increase because products are favored in this instance. Okay, if we add water, again, the system would shift to the left, like we said before, and the NO, which is an additional product on the right-hand side, okay, would then decrease. Very important because we have to use up the excess. So this is actually going to go down as you add more water. Okay, and again, then the reactants would increase. So if we added NO, some more NO, so more product, which concentrations would decrease then? And you would use this concept here, okay, because it's going to shift to the left, and the only things that are going to decrease are all the products. And in this case, it's just water. Okay, so we'll write concentration of water. Now, in the previous lesson, I reminded you that brackets represent concentration. So when we use brackets around a chemical formula, it means the concentration of that particular substance. All right, so let's look at the next thing. When the concentration of a reactant or product is decreased, then the reaction will shift toward, okay, toward the side that has experienced a decrease in concentration because it wants to replace what was taken. So now in this example, and it's very similar to the previous one, but notice the heat, okay? And I just want to point this out to you guys. The heat is on the left-hand side. So this is an endothermic reaction. Just to give you a little idea of what we're looking at here and that you understand this is part of the reaction. It's absorbing heat in order to go forward. So if we remove water, now we have to look for the water. That is a reactant, okay? If we remove water, the system will shift to the left toward where it's removed, so back toward that way. And then the C6H12O6, the sugar, concentration of the sugar, will then decrease. Okay, because then again it's favoring the reactants, so all of this stuff will increase and everything on the right will decrease. If we remove O2, so now I look for O2 and I find O2, and that is a product. So if I remove a product from the system, it will shift to the right toward where it is removed. Okay, it's on the right hand side, so it's going to move toward that side. And then the glucose, okay, will then do what? The sugar will increase because it is going toward the right. So it wants to favor the products. It wants to go that way. Okay, so if we remove glucose, which concentrations will decrease? If we remove this, okay, this is the glucose. If we take away a product, which other concentrations are going to decrease? Well, everything on the left-hand side. So all of the reactants. And in this particular example, CO2, and I'm writing the brackets so you know it's a concentration of CO2, and the concentration of the water. Okay, heat doesn't count. Remember, we don't have a concentration of heat. It's just a measurement. Okay, and if we remove CO2, which concentrations would increase? So if I remove this, remember the shift is going to be toward that side, and then all of the reactants would then increase and everything over here would decrease. So the concentrations of, again, the reactants would increase. Notice the difference between 3 and 4 though, because I removed something on this side. So the concentrations that decrease are going to be everything on the left. But when I remove something on this side, everything will increase and everything over here will decrease. Very confusing, but please take your time to try to remember what's going on here. Here's a little trick though, and this is really a good way to help you remember this. AA, what you add, the system shifts away from. What you take, the system shifts towards. That will help you for concentration only. So remember, for concentration. Because now we're going to look at the other two stresses. Right? Temperature, the initial stress, involves increasing or decreasing the amount of heat component of a reaction. So here, note, heat, energy, joules, kilojoules will either be a reactant or a product. So in this case, you could see heat as a product, so this is exothermic. Okay? And on this side, you see energy, or it might say heat, it might say joules or kilojoules. These are the things that you're looking for. This is going to be endothermic. It's absorbing. All right, so when temperature or heat is increased, okay, the reaction will shift away from the reaction side. It wants to go away from the heat. So if the heat is increased, it wants to go away from that. And that will go in the endothermic direction, whichever that is, based on what side the heat is on. Okay, when temperature is decreased, the shift is going to go toward it because systems don't want to be cold, actually. Okay, it favors the heat. So toward the reaction side containing the heat, and that would then be in the exothermic direction. So here's an example, best way to describe how this happens. Okay, we have ammonia reacting with oxygen gas, okay, to produce water, nitrogen oxide, and heat. So this is exothermic. Heat is released. If we added heat, which concentrations will decrease? Remember, if we add heat, it's going to go away, so it's going to shift to the left. So all of your sorry, okay, so if we added heat, the concentration of everything on that side will decrease because it's all shifting toward the reactants. So all of the reactants would increase and everything on the right would then decrease. So we're going to say all products. Okay, and then if we add heat, which concentrations will increase? Then it would be the reactants. All right, so here's another example. If we remove heat now, so if we're looking at increase, which we've done now, what if we remove it? All right, it wants to go toward the heat. So the heat is on the left-hand side. If we remove heat, then the shift is going to be back toward that side. So it's going to actually go toward the left in this case. And then the concentrations of the products will decrease. Okay, because it's going back toward the reactants. This will all increase. The shift is going to determine the increase in, or decrease in concentration. So all products. Then if we remove heat again, remember the shift is going to the left. Which ones will increase? It will then be all reactants. Okay, in the initial equation, so everything on the left. So it would be CO2 and H2O. Okay, and going back to this, all your products in this case would be CH4 and the O2. Okay? Next, just to add this, all right, if shift is toward products, this will help you remember this too, so add this, then the concentration of the reactants will decrease, and the concentration of the products, as you look at it as a forward reaction, will increase. Now, if the shift is toward the reactants, which would be going to the left, okay, and this helps you go this way. So if the shift's going toward the reactants, then the concentration of the reactants will increase, of course, and then the concentration of the products will then decrease. Okay, last but not least, pressure. How does pressure change the equilibrium? Well, recall, pressure affects only gases. Okay, so every other state, solid, liquid, or aqueous, in the reaction is unaffected for this type of stress. An increase in pressure, the reaction will shift to the side with the least number of gas molecules, or least number of moles of gas, and we're going to practice figuring that out. Decrease in pressure, the reaction will shift to the side with more number gas molecules, okay, or the greatest, I should say. So you could put that greatest number of gas molecules, greater number of moles. So note, if the reaction contains no gas molecules, none, or if the reaction has the same number of gas molecules on each side, there is no effect. Please remember this. So no shift results from an increase or decrease in pressure. Nothing will happen. So here's an example. We have an equilibrium system based on this information, okay, and we have carbon dioxide gas becoming carbon dioxide aqueous. So this is basically taking carbon dioxide gas and dissolving it in a liquid like soda. So if we increase the pressure, the concentrations of which species will increase? Well, according to our rules, the products will increase. Okay, this will increase because we're increasing pressure, remember, and so the gas wants to dissolve in the liquid and become more concentrated. If we increase the pressure, the concentrations of which species will then decrease? Well, it will be the reactants. All right, the gas will then no longer be as concentrated. It will be now forced inside an aqueous solution. If we decrease the pressure, the concentrations of which species will increase. Now, if you decrease the pressure, then the reactants will now increase. And if we decrease the pressure, the concentrations of which species will then decrease. And in this case, it will be the products. Okay? And this is all based on gas molecules. Remember, there's one gas or 1 mole of gas here. Okay? And there's no 0 moles of gas here. So if that helps you, we can figure that out. Remember, the shift is going to go, when you increase pressure, it's going to shift toward the least number of gas molecules. So if we increase pressure, the shift is going to be toward the right, okay, going toward the right, and then an increase in products. If we increase the pressure, again, I'm looking back at number of moles, then again, if the shift is to the right, then everything on the left has to go down. And then it's vice versa for decreasing. Remember, decrease wants to go toward the more moles, which would be the left side. So the shift here, shift is to the left, shift to the left for this one, for the last two. Okay, and if it's shifting to the left, then the reactants will increase and the products will decrease, 3 and 4. All right, so here's another example, a little more complicated here, and then we'll be done with this lesson. Okay, actually there's 2 more examples, I'm sorry. If we increase the pressure for this example, so let's first figure out how many moles we have of everything. So we have 1 mole of gas here and 3 moles of gas here. So I'm looking at the coefficients. So on this side we have 4 moles of gas. On this side we only have 2 moles. All right, so that's going to help us determine where the shift is going to go. So if we increase the pressure, remember it wants to go toward the side with the least number of moles if we increase pressure. So it's going to go to the right. Count moles of gases on each side first. So we did that. All right. If we increase the pressure, the concentration of which species will increase initially? Well, it is a shift to the right, so the concentration of the NH3 will increase initially, or any other product for that matter, but in this case it's the NH3. If we decrease the pressure, so I'm going to put products on the side so you remember that. Okay, that's the rule. If we decrease the pressure, now we're taking it away, so it wants to go toward the side with more moles, so now it's a shift to the left. Okay, and what's going to happen? Which species will decrease initially? Well, if it's going to the left-hand side is going to increase, and then it would be the products would decrease, in this case NH3. Okay, if we decrease pressure again, shifting to the left, the concentration of which species will increase, and that would be the N2 and the H2, okay, or the reactants as we would say. All right, so please jot down any questions. I know this is confusing. I'm going to give you a chart in class that might help you break it down a little easier and then memorize it that way. But what I'd like you to do is just practice this. So with all this information, you have to apply it to actual Regents questions, which gets a little tricky. So for an additional challenge, I'm going to ask you to complete these questions below. You might want to pause the video, copy this down, and go back. So write an I if the concentration is going to increase, a D if it decreases, or R if it will remain the same. Now, we are dealing with gases here, okay? So you need to keep that in mind if any of this is going to affect or not affect certain things, okay? So the first one asks you the stress, if you have an increase in concentration of N2. So we're increasing the concentration of this side. You have to figure out where the direction of the shift is going to go, either to the right or to the left, and then what would the resulting concentrations of a reactant and one of the products. Okay, so this is really saying what's going to happen to the reactants and what's going to happen to the products in this one. Okay. Number 2 asks you about the stress involving temperature. If you increase the temperature, again, determine the direction of the shift and what would the resulting concentration be of NH3, again, which is a reactant, and also N2, which is a product. Okay, so they want to know what the concentration change would be on a reactant and the product side. And then lastly, if you increase the pressure. Now we are dealing with gases, so you will have to figure out number of moles. Figure the direction of shift based on the moles, and then what is the resulting effect on the number of moles of N2, which is a product, and the number of moles of NH3, which is a reactant. Okay, if you have any questions on this, again, we're going to go over it in class, but please try to do this. This would be your challenge for your homework.